Hello, my name is Lei Fang, and I'm a research engineer at QNS, and I'm happy to introduce one of our machines to you. I've been working in QNS for about 7 years, and I've built several machines here. Most of the machines in our center are home-built. When we mean home-built, we really start from scratch. We design all the parts and send the drawing to the manufacturer companies. And after they make them, we assemble them together with thousands of screws and nuts and wires. And then we test the performance, and we have our machines. The advantage of home-built machines is that we can perform some experiments that are not available for commercial ones, and also we can easily upgrade them in-house. For Charlie, the insert part and the STM head, we took the general design of all the other STMs in our center. What's special about it is that we have a fast ramping magnet here. So we can reach a ramping speed of 0.5 Tesla per second in vertical direction and 0.1 Tesla in horizontal direction. Since the magnet is ramping so fast, it could cause large eddy current and generate heat up the STM head. To avoid that, we used lots of PEEK material instead of copper in STM head to reduce the eddy current. And also we use a glass jar for vacuum jacket instead of beryllium copper can. So we don't use that much metal here. So that's the unique property of Charlie. All the systems in our center are named after well-known quantum computing publications and stories. And like we can send information between two adjacent nodes, Alice and Bob. Then researchers were able to demonstrate the teleportation of qubits between Alice and a third node, Charlie, by creating an entanglement between them through Bob. So we already have Alice and Bob in our center. So here you go, Charlie. I think low temperature STMs are very complicated systems, and there are many important things to consider when we construct them. If I need to pick the most important thing, I think it's the low vibrational level. With Charlie, we reach one of the best noise levels in the world of 10 femtometer modulation of the vibration. And to reduce the vibration noise, we have several damping mechanisms. The first is like I'm sitting now on an 80-ton concrete block. So we isolate the system from the rest of the room. And inside the insert, we also have a pendulum structure that isolates the whole insert from the rest of the chamber. So we have very good vibration levels. So after we finished constructing Charlie 2 years ago, we have made several projects here. I think the most interesting project to me is the quantum tunneling in single holmium atom. This experiment is a new method to control the electron spin states of a single holmium atom by exploiting Landau-Zeeman transition probabilities across a hyperfine avoided level crossing. Depending on the speed we ramp the magnetic field, the electron spin reversal is achieved. Since we have a fast ramping magnet in Charlie, it makes it a perfect system for this project. Rather than funny, I would say from this story, I learned that sometimes how simple your problems could be when you are constructing a system. So that's in one of the cooldown tests, we could not reach 1K, no matter how hard we tried and how many parameters we changed. Since it was the initial cooldown, we were suspecting we have something wrong, in our design, or our concepts are wrong. And then later on, we find out that it's because we didn't close the shutter there. That blocks radiation heat from the top to the bottom. Like for a week, all of our group members thought we closed, but we didn't bother to check with each other. So we spent 1 week of really hard work and worry. And in the end, we closed the shutter and we got 1K right away. So yeah, this is kind of funny story to me. Yeah.